Alrighty, so topic 3 is about factoring with the x factor, and I've split it into two parts. This is part 1. And the x factor is a method. It's really just kind of a cutesy name for a method for factoring. It's something that we will learn kind of towards the end of the video. The first part, I'm going to explain why you need the x factor. And this is actually my second time to record this video. So if you're watching this and you think, wait, this is not what she said the first time, it's because I just went back through, I recorded it again, and I'm trying to fill in some of the gaps, some of the questions that people still had after watching the video. So we're going to start by reviewing the two methods that we've learned so far. And the first one we learned was factoring out the GCF, okay, the greatest common factor. And the second one we learned is grouping. Now, this third method is really more like a third step than anything else. Your first step should still always be to factor out the greatest common factor if there is one. That's still the first thing you're going to check on every single problem. So if you look at this problem here, we don't see a greatest common factor. X squared, 7x, and 12, they don't have anything in common. So even though I can't actually do it, I did check for factoring out the greatest common factor, okay? The same way, step 2 is always going to be to see if you can check and group something. So on this problem, I don't have 4 terms, so I can't group. But again, I checked for it. So really, this third thing that we're talking about today, the x factor, is kind of like your third step, the third thing you're going to fall back on if you can't factor out a greatest common factor or you can't group, okay? Now, the problem that's up there, there is no greatest common factor and there's no grouping. So far, we would have called that prime, but it's not prime. I go ahead and over here tell you that this is the factored form of x squared plus 7x plus 12. So if we think about, well, how can I break that down? Well, I've got x squared, when I multiply, x times x squared, x times 3 is 3x, 4 times x is 4x, 4 times 3 is 12. Okay, then I combine like terms, and I've got x squared plus 7x plus 12. What you may notice when we multiply that out is that this middle step right here can be grouped. Okay, we have 4 terms here, right? X squared plus 3x, that would be a grouping, and 4x and 12, that would be another grouping. So what's interesting is that when we're multiplying polynomials, a lot of times we actually had 4 terms, but we turned it into 3 terms. Okay, see how that works? So when I go back to this original problem, what I really want to do is I want to break it apart into 4 terms so that I can group it. And what I see over there is that really I should break it apart into 3x and 4x. Okay, so this 7x, I just broke apart into 2 pieces, 3 and 4. Now I could actually group it and work this out. So I would take out an x, take out a 4, and I get x plus 3x plus 4. Now, what's tricky is knowing how to break it apart, okay? So that x squared plus 7x plus 12, again, that was our original problem. Let me just kind of bring this over here. I need some space. What if instead of doing 3 and 4, I had broken it apart into 6x and x? Let's see if that would still work, okay? Because 6x plus x is still 7x, right? So I haven't changed the value of the problem, but let's see if I can still group it and get the answer. Well, if I group these together, I'm going to get x with x plus 6. If I group these together, there's nothing I can take out except for a 1, and these are not the same, so it didn't work, okay? In the same way, let's take this. I'm going to write kind of small this time. I could rewrite 7x as, let's see, 5 and 2, 5x plus 2x plus 12, right? Because this is still going to make 7x. But if you work that out, it's not going to work. So there's a layer of math you kind of have to do mentally in order to figure out what these 2 middle pieces need to be in order for this to work out. And that's what the x factor is for, okay? So before I show you the x factor, I want to talk about algebra tiles. We talked about these briefly whenever we were multiplying polynomials, and now they're back. So what we've done is we have a problem here, and we've given you already the product, okay, the answer. We want to know what are the factors, which are the things that are along the top and the side, okay? So if you remember, we kind of would draw the little alleyways in between, right? And then we would figure out what was on the inside. Well, this time I've given you the outside, and I want you to find the alleyways. Just move my screen. Oops, hopefully I didn't mess it up. So I know that there's an alleyway here, right? That means that this used to be a big old X. There's an alleyway here, 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 etc. So I have squares all along that. Again, going side to side, got a big ol' x here, square, square. So what I just showed you is factoring. This product right here, I've got a big X squared, I've got 1, 2, 3, 4, 5, 6, 2 negatives makes 4x, then I've got negative 12 here. I took this product and I broke it apart into its two factors. In this case, I'm looking at my side right here, x plus 2, oh wait, not plus 2, negative 2, sorry, x minus 2, x minus 2, and along the top, x plus 6. X plus 6 is this part right here, okay? So that's just a visual of factoring, starting with the area and working your way backwards. It's to be the same as if I said, hey, here's a rectangle and the area is 24. What is this and this, okay? So let's try that again with a and b here. X squared plus 5x plus 6. I'm going to go ahead and start with my x squared here, just because that's kind of where it always goes. And I know that that's going to be the result of x times x. We know that to be true every time. That's the one gimme that we have. But now 5x, that could be written like this, with 5 x's, right? But then I'd have nowhere to put my 6's, because these alleyways aren't matching up to where I have an area for those little 6 single units. So I can't do it that way. Okay, so I can't do 6x. I need to do, or 5x. I need to do maybe like 4 and 1. Okay, well, that would create 1, 2, 3, 4 boxes, and I'm supposed to have 6 down here, so that won't work. Okay, so what if instead of doing 4 and 1, what if I do 3 and 2? That creates my 5x's, and now I see my 6 boxes coming into play. Okay, that is essentially the same thing as us trying to figure out how do I split this middle term so that I can turn it into 4 terms to group it. So that's like me saying, okay, I want 3x and 2x here and 6. Okay, so again, this visual connects to the idea of grouping. And now I can see that I would have 3 here, 2 here, and my factors would be x plus 3 and x plus 2. Okay, that's an x. It's kind of hooky. So let's try this again. Thinking about factoring, what I really want is for this to turn into grouping. So I want this 7x to be split apart into 2 pieces so that I have 4 pieces to group. So maybe it's negative 5x and negative 2x. Maybe it's negative 4x and negative 3x. Maybe it's just negative x and negative 6. We don't know at all, but we know that I'm supposed to have 10 units as well as these x's. So we're going to start with our x squared, as usual. Then I'm supposed to have 7. I think y'all can probably tell it's not going to work for me to just do 7 here, right? Because there's going to be no spot for my 10. So there's 7, but let's take 1 off. What if I take 1 away and add it down on the bottom? Okay, I still have 7 x's here like that. But I'm going to have 1, 2, 3, 4, 5, 6 units. I'm supposed to have 10. So that's not going to work. Oops, wrong button. So I'm going to take off another 1. So now I have 5 up there, and I need 2 down here to make 7. Well, now that's going to leave me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I want. Okay. Now these are supposed to be negatives. So now I see that I've got x minus 5, because these have to be negative, so those bars are negative. And then I've got x minus 2. Okay? Now, as mentioned before with algebra tiles, I do not have the time to draw like 600 little bitty boxes if the number was 600. So there has to be a faster, more algebraic way, and there is. But keep in mind that the whole goal goes back to what we had here, where you want to have 4 terms, because grouping works, right? If you can have 1, 2, 3, 4 terms, we can group it and we're happy. We just need to figure out how to take a trinomial like this and take apart that middle term into 2 pieces, okay? Because we know that that's what happens when you multiply. So let me go here. The x factor is a tool that we're going to use to help us break apart our middle term, okay? So I gave us a new polynomial to work with, x squared minus 5x minus 24. Before we get going, we have to kind of cover one really quick thing. When you have a trinomial, it's actually usually written in this form. A is the number that's in front of the x squared, b is the number in front of the x, and c is the third and last number. So for this polynomial, a in this one is an imaginary 1, b is negative 5, and c is negative 24. What the X factor does over here on the right is it helps us to plan out what we need to split our middle term into. So for the top, we're just going to put our C values, in this case, negative 24. The bottom, the B, is going to be our negative 5. Okay? Now, the two numbers that I'm going to put on the sides here and here need to multiply to give me 24, negative 24, and they need to add to give me negative 5. Okay? So let's talk about the factors of 24. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, again, somehow those have to multiply to give me negative 24. So somebody's got to be negative, but they have to add to give me negative 5. Well, I'm thinking 8 and 3 are going to be our winners. Okay? 8 and 3. However, somebody's got to be negative. Well, since I'm supposed to add to negative 5, I need the 8 to be negative, because 8 plus negative 3 would be positive 5. Okay, what that does is it tells you, voila, that 8, negative 8, and 3 are the numbers that we want to split our middle term into. So I can now rewrite this into 4 pieces, because that's what we like. So I've taken that negative 8 plus 3x from my x factor right here and made the negative 5 into negative 8 and 3. Now I can group. Okay, I can group the first two together, group the second two together. So now I've got x minus 8 times x plus 3. Okay, you also may notice that these two numbers, negative 8 and 3, are what are found here and here. Okay, we'll talk about that a little bit later. So let's do another one. We actually have bukus that we can work on. So I'm going to draw myself an x factor here. Before I get going, I want to make sure that there's not a greatest common factor that I can take out. And there's not. I also want to make sure that I can't already group. And I can't. So now I start working through the x factor. The top is my C, so I've got 28. The bottom is the B, so 11. And when I think about what times what gives me 28 and adds to 11. Well, 1 times 28, 2 times 14, 3 doesn't work, 4 times 7, oh, bingo, 4 and 7. Okay, that's what I'm going to use to break apart this 11 into 2 pieces so that I can group. So x squared plus 4x plus 7x plus 28. Now I can group together these two and these two. I'm going to take out an x, take out a 7. So I've got x plus 4 times x plus 7. And again, you may notice I've got 4 and 7, and I've got 4 and 7. Okay, so let's try the next one, shortcutting it a little bit. X squared plus 8x minus 9. So I'm going to put my C up here, which is negative 9. My B at the bottom, which is 8. Think about my factors of 9. 1 and 9, 3 and 3. Pretty easy one there. I'm thinking 1 and 9 is the only way I'm going to get an 8. Somebody has to be negative, so we think through it. If the 9 was negative, that would make the 8 negative. We don't want that. So 1 has to be the negative guy here. Now, I've shown you a couple times, we actually don't have to go through that whole grouping process. I can just go ahead and write x minus 1, x plus 9, and that's my answer. Okay, because the x's are kind of already figured out for you. X times x is going to give us x squared every time, which is what we're starting with. Okay, so let's look at 3. Again, there's no greatest common factor. I can't group, so I'm going to go to my x factor. Negative 15 is my C. Negative 1 is the B. So I think, okay, factors of 15. That's 1 and 15, 3 and 5. I can't figure out a way for those to add to give me negative 1. That means this guy is prime. Okay? Now, just like I've said before, just because it's hard doesn't mean it's prime. I'm only going to give you like 2% of the problems as prime, so don't just start writing prime everywhere. Okay, I think there's only one more in this set of examples. So I'm going to do one more with you, and then I'll let y'all try some on your own, and then we'll be almost done. So I'm actually going to jump to number 6, just because that one's kind of different. The rest of them I'll have y'all do. So on number 6, there is no greatest common factor, and I definitely can't group it, so I need to put my numbers in. Well, this one looks different, right? There's only two terms. It's a binomial. But what we can't see is that the middle term has a 0 on it. So I could actually rewrite this as k squared plus 0k, oops, k, minus 49, right? Because 0 times whatever is going to cancel out. So we don't typically write that. But I need it in this case because my b value is that 0 that I don't see. And c is the negative 49, okay? So now what times what gives me negative 49 and adds to 0? Well, 7 and negative 7. Shortcut says that I can just take these two pieces. So k plus 7 times k minus 7. Okay? Alrighty. I feel like now would be a good time to pause, try some. I'm going to pause as well and work these all out and then show you my answers. Alrighty, so here's my answer. I'm actually going to start at the bottom here just because that's where I am. So number 4, we got x minus 4 and x plus 3. Number 7 was actually prime. There's no factors of 24 that will add to give me negative 4. And then 8 was x plus 8 times x plus 8. You could also write as x plus 8 squared. And then at the top, x minus 9 times x minus 1. Alrighty. So now, number 9, just kind of a random problem. You could probably do this one on your own if you want to pause and try it. But again, it's just the x factor. So I've got negative 24 on the top, negative 10 on the bottom. So I think about my factors that will add to negative 10 and multiply to 24. I think it's 12 and 2. One of them has to be negative. Yep. So I've got x minus 12 and x plus 2. Okay, so now the very bottom part of your paper says consider the following what is different. With these 4, what's different is that the a value is not 1. Okay, and all of these, we have a value in front of our x squared. If you look back at the page before, none of these had a value in front of x squared, or n squared, or k squared, okay? And you do have to treat them differently. However, I told y'all initially that the step 1, the topic 1, factor out the greatest common factor, that's still going to be the first thing you check for no matter what. So looking at number 10, do I have a greatest common factor? And the answer is yes. Between all 3 of those terms, I know that I can take out a 2, okay? So I'm going to rewrite this as 2 times x squared plus x minus 2. Now, I'm not done. Even though I did something, I'm not done. I can actually continue with the inside portion using the x factor, okay? So with just the inside portion, my c is negative 2 and my b is 1. So I can actually rewrite this as 2 times, oh, I'm finished. Jumped ahead there. So I think of my 2 numbers on either side that will multiply to negative 2 and add to 1. So I'm thinking 2 and 1. Those are the only factors of negative 2 there are. And 1 has to be negative here. So I've got x minus 1, x plus 2. And that would be our final answer here. Okay, so let me do one more with you. I'm going to factor out the greatest common factor first. So in this case, it is a, actually I'm going to go across number 12. Do this one. It is a 6. Okay, so I've got x squared plus 11x plus 10. And even though I've done something, I'm still not going to call it done because I can do the x factor with what's left over on the inside. So in the inside, my c is 10 and my b is 11. So I've got 1 times 10, 5 times 2, so obviously 1 times 10. So I've got 6 times x plus 1, x plus 10. And that's my answer. So y'all try the bottom 2 on your own. Go ahead and pause it, and then when you resume, I should have your answers ready. Alrighty, here's your answers. So number 11 was 4 times x minus 2 and x plus 1. And 13 was 5 times x minus 4 and x minus 2. It's not going to be correct if you forget to take out that greatest common factor. So make sure that you do that first and foremost on every single problem. If it looks like there's a greatest common factor between all the terms, you have to take that out first no matter what. Alrighty, let me know if you have any questions.